So in this video, we are going to talk about the sum, which means additions, and the difference, another way to say subtraction identities, and that is the most useful and often used in trigonometry, along with the Pythagorean identity, and we use it to define the trigonometric values. So in this video, let's think about the main purpose of applying the sum and difference identities to the trigonometry, and think about these sum formulas of sine, cosine, and tangent, and the difference identity, which is also has the sine, also has to do with sine, cosine, as well as tangent. So firstly, let's start off by thinking, why should we apply the sum and difference identities for defining the trig values such as sine, cosine, and tangent? The main purpose of using the sum and difference identity is to basically define the trig values. And the trig values means like trigonometric values such as the sine, cosine, and tangent. But the most important thing is, using the sum and difference identities, we can define the trig values of any angle measurements. And the reason why is this important is because so far, such as while we're graphing the trig values, we can only think about the trig values of the main angle that are manipulated by the special angles, which are pi over 6 radian, pi over 4 radian, and pi over 3 radian. However, we cannot define the angle measurements that are not related to the special angles. However, by manipulating these angle measurements, by using their sum and difference between them, we'll be able to define the sine, cosine, and tangent, also their inverses on the unit circle of any angle measurements. So that's why the sum and difference identities are important, along with the Pythagorean identities. So firstly, what we're going to do is explain firstly the sum identities of sine, cosine, as well as tangent, and the difference identities of sine, cosine, and tangent, with one example to refresh our brain about this concept and think about how to memorize them. So let's remove the thing that I color recorded right now to not to get confused with the writings that I'm going to write right now. So after rearranging these values, let's think about each values of sine, cosine, and tangent sum and difference identities. I will erase the things that we did, but before we start with the formula, the concept for applying the sum and difference identities is, let's say there are angle measurements that we cannot express, but we need to express them in terms of the special angles. Well, we need to express with the two special angles among the pi over 6 radian, pi over 4 radian, and the pi over 3 radian, which are 60 degrees, 45 degrees, and 30 degrees. So we can either add two of these special angles, or subtract those two of those three angles. Also, when we define the cosine, the same thing, we can split up the one angle measurements in terms of the two special angles. We can either do additions and subtractions between them. And also, that will be applied to the tangent. So this is the basic concept for sum and difference identities. Now let's start by thinking, what is the sum identities of sine of alpha plus beta? When we see that alpha is the first special angle and the beta is a second special angle, which are the random angles among these. So the alpha and the beta, so if we set the alpha as the first special angle among these three of them, among the pi over 6 radian, pi over 4 radian, as well as pi over 3 radian, and beta also one of these special angles, and we don't care if the alpha and beta are exactly equivalent. All you have to do is express an angle measurements in terms of the two special angles. So if you're thinking of the sum identities of the sine, where we add those two special angles to form one angle measurements, then the formula will be like this. It will be the sine of the first angle, which is alpha in this case, times the cosine of the second angle, which is beta, plus the cosine of the first angle, alpha times the sine of the second angle beta. And this is the formula for the sum identities for the sine. So again, when we're thinking of the sum identities for the sine, where we add those two of those special angles to form one angle measurements that we cannot express easily on the unit circle, then the formula will be the sine of the first angle measurements times the cosine of the second angle measurements plus the cosine of the first angle rotations times the sine of the second angle rotations. And when they're being added, when we're thinking of the sum identities, they will always be two expressions. And if it's the sum identities, we're always going to write the plus sign to relate these two expressions. This is the sum identity for the sine. And after explaining the sine difference identities, which is closely related to the sum identities of sine, then let's think about how to remember it for applying it to the real questions. So also, if you assume that the alpha is the first angle measurements among these three special angles and the beta as the second angle measurements, then we can say that when we're thinking of the difference identities, which means when we subtract the two special angles to form one angle measurements, then the formula will be closely related to the sum identities. So let's write down the sum identities. Sine of the first angle, alpha, times the cosine of the second angle, beta, and the cosine of the first angle, alpha, times the sine of the second angle. And as we can see, the sine of alpha minus beta and sine of alpha plus beta are closely related. We have sine of the first angle alpha times the cosine of the second angle beta, cosine of the first angle alpha times the sine of the second angle beta. And just like the sum identities, we have the two expressions as sine times cosine and cosine times sine. When it was the sum identities, we made a plus sign to relate these two expressions. However, when we're thinking of the difference identities for the sine, it will always be related as the negative sign. So don't forget to write down the negative sign when it is a difference identities and the plus sign when it is a sum identities for a sine. So this was the sum and difference identities for sine, and even though it looks a little bit weird first time when we're memorizing it, but let's think about how to memorize these two values in my own way. So if you just memorize the sum identities, for example, then we don't have to memorize the difference identities because the only thing that are different are the symbols. So the way I memorize the, for example, sum identities for sine is by using the pronunciations of each letters. So the sine, there is sine, cosine, cosine, and a sine. So let's think about how to memorize it. But for angle, we don't have to memorize it because the angle is just alpha, beta, and then alpha, beta, and the alpha, beta. The pattern will keep up until the end. All you have to memorize is these values. How can we memorize the sine, cosine, cosine, and a sine in an order? So let's start with the cosine. The cosine is a little bit different with the sum identities for sine, just like I mentioned. So there is also a way to memorize the cosine sum identities. Again, when we're dealing with the sum identities, that is because the two special angles where the alpha and beta are just one of those three special angles, and they're being added, then the cosine sum identities is defined in this way. Cosine of the first angle, alpha, times the cosine of the second angle, beta, but minus the sine of the first angle, alpha, times the sine of the second angle, beta. So unlike the sine, because for the sine of alpha plus beta, when it was the sum identities, the two expressions were being added. However, for the cosine, if it's a sum identities, then the two expressions will be subtracted. And for cosine of alpha plus beta, it'll be cosine of the first angle times the cosine of the second angle minus, when it's a sum identity, sine of the first angle times the sine of the second angle. So if this is a cosine of alpha plus beta, then the cosine of alpha minus beta, which is a difference identities, will have exactly equivalent expression except for the symbol. So that means if the cosine of alpha minus beta, where the first special angle is being subtracted by another special angle to form one angle measurements or rotations, then it will be the cosine of the alpha, first angle, times the cosine of the beta, just like the cosine alpha plus beta, sine of the alpha, times the sine of the beta, except when it is a negative, a difference identities, the expressions that the term that relates these two expressions will be a positive. So we'll add them when it is a cosine difference identities. We'll subtract them when it is a cosine sum identities. So this is a cosine, not a sine, so there is also a way to memorize them. And again, just like I mentioned while we were doing the sum and difference identities for sine, the alpha, beta, the angle has a same pattern, so we don't have to memorize them. Alpha, beta. For sine, if it was sin, cosine, for the sine, cosine, and sine, then to memorize the cosine, where it has the pattern, cosine, sine, and sine, just like I did for the sines, sum and difference identities, we will memorize it using how it is pronounced. So when we do the cosine of identities, also, just like we did sine, if you just memorize the sum identities, then the difference identities will automatically be memorized. So for cosine of alpha plus beta, when it's a sum identity, we memorize like this. We already know that it has this always, for the sine, cosine, and tangent, they have the same pattern of the angle measurement as the alpha, beta. And for cosine of sum identities, it'll be sine, and sin. This is how we memorize the cosine sum identities. So again, it will be sine, and sin, and we memorize the cosine, sine, and sine by the way it is pronounced, and again, the angle has a same pattern. So that means automatically the cosines alpha minus beta, which is a difference identities, will be sine with the same angle pattern, but except if it was negative from the sum identities, then it will be positive in a difference identities for cosine. This is how we memorize the two cosine sum and difference identities. And now after I erase the things I did in a cosine and a sine, not to be confused, and to memorize it using the way I did for approaching the questions that we're going to solve in the next videos, let's think about the last one, which is tangent of the alpha plus beta. So when we're thinking of the tangent sum identities, that means one of those special angles. For example, alpha should be one of those three special angles among the pi over 6 radian, pi over 4 radian, and a pi over 3 radian. And also beta should also be one of them. But since we know that the tangent, originally, if you're not thinking of the sum and difference, is a proportions between the sine and a cosine. So when we're thinking of the ratios, we always like to write it in terms of the fractions. So inside the numerator, when it is alpha plus beta, the tangent sum identities will be written in this way. Tangent of the first angle, alpha, plus the tangent of the second angle, beta, over 1 minus the tangent of the first angle, alpha, times the tangent of the second angle, beta. I won't explain how this is written like this way, because this video is basically about introducing the sum and difference identities and think about how to apply it to the real questions. So if the tangent alpha plus beta, which is the tangent sum identities, is written as the tangent first angle, tangent of the second angle, and they're going to be added in the numerator. And inside the denominator, it will be written as 1 minus the multiplications between the tangent of alpha times the tangent of beta. So that means we can easily write the difference formula for the tangent. If we were thinking of the tangent of the alpha minus beta, then it will be same thing with saying the tangent of alpha plus beta, except the symbol will be opposite. So the tangent of alpha minus beta will also be written in terms of the fractions, but it will have a opposite symbol. So if it's tangent of alpha minus beta, then it will be written as the tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha times the tangent of beta, which is exactly the same statement except the symbol is different with the sum identities of tangent. So for the difference identities, it will be the tangent of the first angle minus, when it is the tangent, when it is the minus inside the numerator, it will be the negative tangent of the second angle. And if it's the difference identities inside the denominator, it will be 1 plus the multiplications between two things, tangent alpha times the tangent of beta. So this will be tangent of alpha minus beta. So this was the two identities for the tangent, sum and difference identities. And there are, for sine and cosine, there are ways to memorize it using how the words are pronounced. However, for the tangent, there is no other way to memorize it, but the only thing that we can think about for a tangent, sum and difference identity is this way. When it is the positive, so the sum identities between the two angle measurements or the angle rotations for the tangent, then it will be consisted of the numerator and denominator, because the tangent is a ratio between the sine and the cosine. So for the tangent, just like the sine value, so when we're thinking of the tangent, it is sine over cosine. So the numerator must be related to the sine, and denominator must be related to the cosine. But just like we saw up here, when for the sine, for the sum identities, when it is plus, then the two expressions will be related with the additions. So when it is plus, just like the sine in the numerator, the two terms, tangent alpha and the tangent beta, will be connected with a plus sign. However, for the denominator, we always need to not forget the positive one. And for denominator, it has to do something with cosine. And for cosine, for the cosine sum identities, when we have the two angle rotations and they're adding together, then it must be connected with the negative sign among or between these two expressions. So it'll be 1 minus the multiplications between two terms, tangent of alpha and the tangent of beta. That means obviously the tangent of alpha minus beta, which is the difference identities for the tangent, it will be tangent alpha, tangent beta, except it is a difference identities. So if it's a minus, just like the sine, when it is minus, the two terms are going to be related with the negative sign. And just like the cosine, when it is a difference identities inside the denominator, the two expressions, cosine alpha times cosine beta, sine alpha times sine beta, will be connected with the positive sign. So just like the cosine property and denominator for the tangent of difference identities, the two terms, 1 and a tangent alpha times tangent beta, will be added together. So this was the tangent alpha plus beta and tangent of alpha minus beta. So there are basically three things to remember: the sum and difference identities for the sine, cosine, and tangent. So using these values, after we erased the thing that we marked here, except for the identities that we wrote, let's solve the one short question to refresh our brain about this concept, sum and difference identities. So the question is to solve the sine, cosine, as well as the tangent of 105 degrees. And obviously we can figure out that 105 degrees is not an angle. We can notate it using the sine and a cosine, but we can manipulate it using the two of these special angles, pi over 6 radian, pi over 4 radian, as well as pi over 3 radian. And again, if you're not familiar with this, again, pi over 6 radian is 30 degrees, pi over 4 radian is 45 degrees, and pi over 3 radian is 6 degrees. And adding or subtracting one of those, two of those angle measurements among the three special angles, we need to manipulate the 105 degrees. But we can easily realize, because we learned the additions, 105 degrees is same thing with saying 60 degrees plus 45 degrees. That means 105 degrees can be notated using the special angle pi over 4 radian and a pi over 3 radian. So this is same thing as saying pi over 3 radian plus the pi over 4 radian. So it will be the pi over 3 radian plus the pi over 4 radian. So firstly, let's solve the what is the sine of our main angle 105 degrees. But luckily for us, we can manipulate the 105 degrees to the additions of the two special angles as pi over 3 radian and a pi over 4 radian. So this is the same thing as saying sine of pi over 3 radian plus pi over 4 radian. And now we're in a situation where the two special angles where we notate it as the alpha and the beta while we are explaining the sum difference identities for sine. So this is sine sum identities. Well, the two special angles are pi over 3 radian and a pi over 4 radian. So if you calculate the sine of pi over 3 radian plus pi over 4 radian, simply just think about the pi over 3 as the alpha and pi over 4 as the beta. Then what is the formula we can apply? Memorize the sine sum identities by the how it is pronounced. We memorized it as sine cosine, where it is sine and co and sine. And we always need to remember that the angle measurements are always in the same pattern. The angle measurements are alpha, beta, and an alpha and a beta. This is how we remembered it. So after we give some space, then we need to remember that this is the sine, this sum identity for sine. That means they need to be multiplied together, and the two expressions will be connected by the positive sign, plus. So again, we apply the sine formula where it is sine cosine, just like we memorized, where the main angles are alpha, beta. And since we know that it is a sine sum identity, so when they are plus, this will also be the positive. So all you have to do is solve for the values of each trigonometric values. But what is the alpha in this case? In this case, the alpha is the first angle measurement, pi over 3. So this is sine of pi over 3 times the cosine of beta. What is the beta? We define it as the pi over 4 radian. We have plus the cosine of the first angle, which is pi over 3 radian again. And times the sine of the beta, and the beta again is pi over 4 radian. And all you have to do is using the right triangle ratios that we talked about in our previous videos, we need to do it. And if you're not familiar with the right triangle ratio, which I'm going to explain right now, you need to go back to my previous video about the right triangle ratios and how to memorize them. When it was the sine of pi over 3 radian, what was the value? When it is pi over 3 radian 6 degrees, then the sine was square root of 3 over 2. Multiplied by the cosine of pi over 4 radian. We define the cosine of pi over 4 radian as square root over 2. We have plus the cosine of pi over 3 radian is equal to 1 over 2 times the sine of the pi over 4 radian, which is square root of 2 over 2. So all you have to do is simplify it. What is square root of 3 over 2 times square root over 2? Well, we can figure out that they have the denominator as 2 times 2, 4. And we have the numerator as the multiplications of the radical, square root of 3 times square root of 2. Plus the cosine of pi over 3, which is 1 over 2 times square root over 2. Inside the numerator, 1 times square root of 2 is square root of 2. Over 2 times 2 is positive 4. Now we can figure out that they have a common base. We can add them. But according to the property we learned, if they have the radical and they're being multiplied, we can multiply, have one radical, and inside the factor will be multiplied. In this case, it will be positive 6. Plus the square root of 2 inside the numerator. And there is no other way to simplify it. So square root of 6 plus square root of 2, all of that over 4. This will be the value for the sine of 105 degrees using the properties of Cosine Sum Identity. So after shrinking this values that we wrote right now, for the space to write the cosine to define the cosine of 105 degrees. We need to define what is the cosine of 105 degrees. And again, right now I'm going to explain a little bit faster because we're kind of reviewing what we did for the sum and difference identities. And from the next video, we're going to explain a little bit more detail while we're solving the questions. Again, we're trying to solve the cosine of 105 degrees, but we split up the 105 degrees with two special angles, x 60 degrees, plus 45 degrees, which are pi over 3 plus pi over 4, just like I did in a sine. Sine of pi over 3 plus sine of pi over 4 radian. So that means we can also fix the cosine of 105 degrees as the cosine. 105 degrees can be split up as pi over 3 radian plus the pi over 4 radian. And also we have the cosine of the term, and we have the two special angles, and they're being added together. That means we can apply the cosine sum identity, which is the cosine of alpha plus beta, where alpha and beta are both special angles. So what was the cosine formula that we remembered? We memorized as cosine sine. So sine and sine. So let's give a space to these letters. And we need to remember what was done. So the cosine was remembered as cosine sine, and their special angle had the same pattern with the sine as the alpha, beta, alpha, beta. This is the cosine of 105 degrees. And again, if they're cosine of 105 degrees, they need to be multiplied to have the two expressions. But unlike the sine, if you have the two expressions, like cosine alpha times cosine beta and sine alpha times sine beta, they need to be subtracted to form a cosine sum identity. So we have the two terms, cosine alpha times cosine beta minus sine alpha times sine beta. But we need to replace those terms. What was the alpha? We set the alpha as pi over 3 radian. So this one will be cosine of pi over 3 radian times the cosine of the beta, where beta was written as the pi over 4 radian right over here. Cosine of pi over 4 radian. And then minus the sine of the alpha, where alpha is pi over 3 radian, times the sine of the beta, and the beta was pi over 4 radian. All you have to do is simplify these expressions to get the value. Using the right triangle ratios, what is cosine of pi over 3 radian? Well, that was 1 over 2. Multiply by cosine pi over 4 radian, which we know as square root of 2 over 2, minus the sine of pi over 3 radian, which is square root of 3 over 2, multiplied by sine of pi over 4 radian, which we know as square root of 2 over 2. All you have to do is simplify them. So 1 over 2 times square root of 2 over 2 is same thing as, they have a base as positive 2 and positive 2. So denominator will be positive 4. In the numerator, it will be 1 times square root of 2 minus 2 times 2. So the denominator will be formed as 4 square root of 3 times square root of 2. So this has this common base as a positive 4. So this can be written as 4 in denominator. And square root of 2 minus square root of 3 times square root of 3, just like I mentioned above. If they have the multiplications between the radicals, it will be written as the one radical, and instead the factor, which is 3 and 2 in this case, will be multiplied together. And there are no other ways to simplify this more. So square root of 2 minus square root of 6 over 4 will be the answer of cosine 105 degrees using our sum identity for the cosine of pi over 3 plus pi over 4 radian, cosine of alpha plus beta. So after shrinking the cosine 105 degrees and the work I did right now to solve the last question for the tangent of 105 degrees. For dealing with the tangent of 105 degrees, we can also write the 105 degrees as the tangent of pi over 3 radian plus the pi over 4 radian, just like we did for the sine and the cosine identities. Then we can figure out that it is a tangent and there are two special angles and they're being connected with a positive sign. That means we can apply the tangent of alpha plus beta, the tangent of alpha plus beta, where the alpha in this case is tangent of alpha where alpha is pi over 3 radian, plus the beta is pi over 4 radian. So if you apply the formula, I will explain quickly right now. So the formula was the tangent alpha, because we're thinking of the tangent alpha plus beta. If they're plus alpha plus beta, then with the pi over 3 plus pi over 4, it'll be pi over 3 plus the tangent of pi over 4 over the tangent of not tangent but 1 minus the multiplications of two values, pi over 3 times the tangent of pi over 4 radian. So if you simplify this, we will get the answer. So tangent of pi over 3 radian plus the tangent of pi over 4 radian. In the numerator, it will be connected with a positive sign because it's a tangent of alpha plus beta, tangent of pi over 3 plus pi over 4. Inside the denominator, it will be connected as the negative sign, 1 minus tangent of pi over 3 radian times the tangent of pi over 4 radian. If it's simplified, the tangent of pi over 3 is square root of 3. Tangent of pi over 4 is positive 1. Again, tangent of pi over 3 is square root of 3. Tangent of pi over 4 is positive 1. So this will be written as square root of 3 plus 1 over 1 minus square root of 3 times 1, where it is just equal to square root of 3 plus 1 over 1 minus square root of 3. So after shrinking the work I did, let's finalize our answer by rationalizing it. This is not 1 plus square root of 3, that must be 1 minus square root of 3. So we need to simplify the square root of 3 over 1 minus square root of 3 times 1, which is just equal to square root of 3 plus 1 over 1 minus square root of 3. And we need to rationalize the bottom denominator to rationalize the answer, to finalize it. And to do it, we have the square root of 3 plus 1 over 1 minus square root of 3. And just like we learned before, to cancel out the term, inside the denominator, we basically need to cancel out the square root. That means we need to multiply them by the opposite symbol for it. So if it's 1 minus square root of 3, we call it as the conjugate at 1 plus square root of 3. So since we multiply the numerator, denominator, we also need to multiply it inside the numerator. So if you multiply it in the denominator, if you using the property that we learned in a previous video about the factoring, 1 minus square root of 3 times 1 plus square root of 3 will be equal to 1 minus positive 3. Square root of 3 plus 1 times 1 plus square root of 3 will be same thing as, it will be 1 plus 2 square root of 3 plus 3. So if you simplify, the 1 minus 3 will be equal to minus 2 over negative 2. 1 plus 2 square root of 3 plus 3, we can combine the like terms as 1 plus 3 as 4 plus 2 square root of 3. And there are no more terms we can simplify, so 4 plus 2 square root of 3 over minus 2 will be the value for a tangent of 105 degrees, where we apply the sum identities for the tangent. So this was the question for finding the sine, cosine, and tangent of 105 degrees by manipulating the 105 degrees into the two special angles that we know already. So if you did already review here, we are talking about sum and difference identities. And the reason is because we want to find the trig values of any angles that we cannot express it using the right triangle ratios on the unit circle. And we do it by using the properties of sum and difference of the special angles, pi over 6 radian, pi over 4 radian, and pi over 3 radian. And for the sines, sum identities, it is sine of alpha plus beta, where alpha and beta are the two special angles we already know, and we need to add it to manipulate it for splitting up the angle that we cannot express using the right triangle ratios. And the difference identities, the reason why it's called a difference is because we make one angle measurements into the two special angle subtractions. And also same thing with for the cosine of the alpha plus beta, cosine of alpha minus beta, tangent of alpha plus beta, and tangent of alpha minus beta. And only thing that we have to remember is the standard sum identities for sine, cosine, and tangent. And the reason is because the sine, cosine, and tangent sum identities, like this, and this, are exactly equivalent with the tangent alpha minus beta, cosine alpha minus beta, or sine alpha minus beta, which is a difference identity except it has a opposite symbol. So there was a way to memorize the sine of alpha plus beta. The angle will always have the pattern of alpha, beta, alpha, beta, alpha, beta, alpha, beta. And there will always be the two expressions also in a sine and a cosine. For tangent, there will be the numerator and denominator, because the tangent is a ratio between the sine and a cosine. And the way to memorize it, for example, for sine, we use it by using the how it is pronounced. For sine, it will be sine cosine, just like how it's pronounced. And also for a sine of alpha minus beta as sine cosine, except when it is a sine of alpha plus beta, the two expressions will be plus, and when it's sine of alpha minus beta, it will be negative. And for cosine, we can apply just exactly same how it's pronounced. And for cosine, alpha plus beta will be cosine, and sine, except when it is a plus, it will be negative, unlike the sine's sum identity. So for cosine of alpha minus beta, it will also be same as cosine with the same pattern of the angle measurement as alpha, beta. And when it is minus, it will be positive. And for tangent alpha plus beta, there are no other ways to memorize it, but we need to remember that the tangent is a ratio between sine and a cosine. So sine over cosine is the tangent. So numerator has something to do with sine, and denominator has something to do with cosine. For alpha plus beta, if it's a positive sign in the numerator, just like the sine property, they'll be connected as positive as tangent alpha and a tangent beta. And the denominator, when it's plus using the property of cosine, it will be 1. It always starts off 1 minus the tangent of alpha times the tangent of the beta. And again, when it is minus alpha minus beta, that is the difference identity for a tangent, that it will have the exactly same value except for the opposite symbol. And this is the sum and difference identities. And in the next video, we're going to solve more questions to be familiar with these identities, to so we can drag out other or lots of identities we can use that are useful or often used for solving the trigonometry.